Welcome to Playing with Junk again. Today I have some medical equipment here. It's a Draeger Cato Anesthesia Ventilator. That's how this thing is called. It's the model number M33000. And that's basically the machine that makes you sleep when a big operation is surgery is planned. So that machine mixes oxygen, air and nitrous oxide together in the right proportions to make the patient sleep very deep without feeling any pain. Here we have the inlets for oxygen, air and nitrous oxide from the hospital power supply. Then we have oxygen and nitrous oxide from bottles, so that's the backup in an emergency situation. Then typical for medical equipment is this additional earth plug. That's very important, not that the patient gets hurt by an electric shock. Here is the control panel. Unfortunately, this machine has no power supply, so we can't play with it. It doesn't show anything. Well, let's take it apart. I'm not a specialist for these medical parts, but well, we will see how it works by looking inside. First step is opening that lever and remove that part here, which is some sort of filter, maybe a moisture filter unit that removes moisture from the gases here. This is the pump unit. There is a rubber bellows inside here. It's a little bit jammed. It goes out like this. Looks like that. Looks like some part of an atomic bomb or something. So this container is normally filled up to here with lime or magnesium hydroxide or chalk. Don't know how you say it. It's for the absorption of carbon dioxide that comes from the patient through the hose that is connected here. That's the hose that goes out to the patient, where he breathed the mixture of gases here. There are various gas inlets and outlets. And here is a very interesting part. It's some sort of flow measurement device. I have no idea how it works. The only thing you can see is on the 4 golden needles here. There are 2 very, very fine wires. One goes from the leftmost needle to the rightmost needle, and the other goes diagonally from the one short needle to the other short needle. I don't know if they heat it up electrically and then measure the cooling of the wire, or I don't know what exactly they do. Maybe we can find out a little bit later. So this here is a little bit unexpected. I expected to have a bellows that folds up and down, but this is more like a piston pump, but it has a rolling rubber gasket here, which rolls around the inner piston and seals it completely. So that's the way how the gas mixture is pumped. So what you adjust is how much it pumps, only a short way or the full way, depending on size of the patient or of the patient's lung or whatever you need to know. That's what the control box here, what you adjust here. Okay. Yes, it's very tight. Would be a good air pump anyway. Here we have some pieces of electronics. Let's see how that looks like. Comes off very easy. Looks like a processor card. CPU MC6802. Some RAMs. Some more stuff. 68B21, could be some I/O ports. And even more of such stuff, more EPROMs. That could be a RAM, is it? No, have to look at. 68B21. Yes, it's the same. So I think that's a lot of digital I/O port stuff. Okay, that was only the bumper here. Let's see how we can remove that panel. If you need a source for stainless steel, screws and other parts, buy one of these. Oh, okay. It's not too much inside, just a display, some buttons, a controller chip, and this weird hybrid modules, custom made by Draeger. Nice rotary encoder. Okay, some more of these ceramic modules. Well, there is not a lot of electronics inside here. because most parts here work with air, pneumatically. Okay. So we expect a lot of hoses and lines and pressure sensors. This one is interesting. It looks like a magnet from a speaker, and on top there is a block of aluminium with two wires, red and blue. Maybe it's some sort of shaker, maybe it's some sort of loudspeaker, I don't know. We have a battery, nickel cadmium rechargeable battery here, with a good battery holder, something I can use later. Off, but it is attached to something rubbery. Okay, that's a little bit more of it. Some power drivers, maybe for the main pump here, back somewhere. A lot of hoses, a lot of pneumatic valves. This looks like a pressure sensor for the different types of gas we have here. By the way, nitrous oxide, some call it laughing gas. It's the same as you get when you go to the dentist, or you can make your car go faster or explode, depends on the type of car you have. So let's see what this thing here is doing. Maybe it's a small pump for something, or a valve. Okay, I need a cutter. Okay, it says 38.3 ohms, whatever that means. It has two connections, maybe an input and an output magnet. So I think this is an electromechanical pump, maybe. Let's see inside. Some people call me a vandal with a screwdriver, but that's not true. I have pliers too. So, I think that's coming apart now. Oops. There is, ooh, something nice. Looks like a rotating device. Okay, there's not much here. Oops. Okay. Oh, there is a diaphragm, some rubber piston device thing. So I think this is not rotating. It's pushing up and down like that. Oops. Yeah, it's like I said, it looks like a magnet from a loudspeaker, and it works like a loudspeaker. Pushes on that. Where is it? Is it gone? Okay. Oh, here. Pushes on that rubber silicon diaphragm here, and then pumps air or whatever from one house to the other. Okay, that's the motherboard. Can you see that? They couldn't decide if they want to speak German or English. They called it Mutterboard. Divan. Okay, the divine motherboard. Can you see all these parts? Are there any model aircraft or model car makers around? You know what they cost if you have to buy them. A couple of bucks each one of them. And this machine is full of this stuff. Let's go further. Okay, after loosening some screws on the bottom side, I can remove this unit here. Okay, let's have a look at the pump mechanism here. So that's the pump piston. Slides in like that. Locks like that. And then the pump will pump like that. And of course, depending on the settings, it will do a larger stroke with more volume, or just a shorter stroke, maybe for a child or something. Then going to the park position, lift the lever and you can change the piston if necessary. And whenever you see this green dust here, this fuzzy greenish grayish dust, this is from the operation towels. I always say operation because that's in German, from the surgery towels and all those blankets. They are mostly green, and all that dust here comes from all that green tissue towel stuff. Okay, another interesting part here, a little filter on the with a green border, and I would say it's some kind of pressure regulator. Yes, could be. Okay, let's have a look at the pump here, or the pump drive. It's not the entire pump. So I'm a little bit surprised that this is not a stepper motor. This looks like a regular DC motor, which has already seen better days. I don't think that I have damaged this here. I just took it out. So maybe someone else has already screwed around. From ABB. Asea Brown Boveri, or, well, it's a Japanese brand, as you can see here. Makes more sense. Then we have an encoder here, counting the steps, and we have some encoder looking part here. What is it? Yeah, I think that's the precision measurement, that it goes to that axle here, which drives the piston through the belts here. So that must be some kind of quite expensive rotary encoder, step counter, however you want to call that. Yes, that's exactly what I thought it is. There's a glass plate, a glass disc with some engraved lines, which is turning together with the axle. And then we have some optical sensors, maybe on this side here. Yes, looks like. So they are measuring the way that piston mover moves. By the way, this floor here is brand new, and it is perfect to loose screws. Can you see the screws? No, they are here. They match perfectly in color with the floor, and you have no chance to find them again. A nice motor. It's a brush, 4-brush DC motor, 2 positive, 2 negative brushes, and it's covered with the same green dust as you always have in medical equipment. Funny arrangement of the magnets here. Are they magnets? Maybe. Or a little bit loosey-goosey here. Don't know what the trick is about this. Maybe we find a data sheet somewhere. Maybe not. Okay, that's about the heaviest part of the entire machine. Power supply. I expect a big mains transformer inside. An insulating transformer, perhaps. Well, let's see if I'm right. Okay, that's it. Power supply, well, input capacitors, transformers, all the usual stuff, and we have a big blue transformer. That's heavy. So compare it with my hand, that's a big one, and I'm sure it has this blue color because it's medical approved, 1000% safe and extremely expensive. Then we have the back side of a big button, a big switch. What does it switch? Oh, the input voltage from 100 to 240 volt. It's now set to 230, which is absolutely correct. And then we have some outlet plugs here, which are covered by this plastic cover here. Let's see how it looks without it. The problem here, or the reason why it is covered, is that there are so-called Schuko plugs, which are used in Germany and Eastern Europe and some other parts of Europe, but they are not used in Switzerland. So they simply covered that because they didn't want that someone uses it here. For example, in Germany, I'm pretty sure this cover is not in place and they can use it for external devices. They can use the insulation transformer, the big blue one, to power. So we have maximum 2 amps, okay, per socket makes 8 amps. That's about, well, maybe a 1 kilowatt transformer, or maybe a little bit more, something around that big relay. A smaller transformer to provide some auxiliary voltages. Well, not that exciting, but a nice blue transformer. Last part, the part up here. Here is a compartment for some accessories. Just plastic door, maybe could even be wood. There's a switch that switches from nitrous oxide to air. For example, when the surgery is over, to wake up the patients, you go from the narcotic to fresh air. Then you can give it some extra oxygen, maybe to wake up or for whatever reason. Then you have here variable regulators for O2, oxygen, air, nitrous oxide with the flow indicator here. That's a little piston here that moves up depending on how much air you blow through that tube. There are 3 nice little pressure gauges. Okay, let's see inside. Okay, all the hoses are already cut away. Oops, the glass is coming off. It's a security safety glass with 2 layers and something in between, because you could have probably high pressures here, and if something bursts, it's not good if it flies in your eyes. Then we have an inverter with 2 cables that go to this background illumination. It's some sort of electroluminescent illumination. Let's see if we can power that up. I'm not sure what input voltage we need. It looks a little bit like a mains cable, maybe 230 volts. I'm not sure. Maybe I better start with a lower voltage, or unscrew the cover and maybe we find that out. There is some sort of, I don't know, switching valve regulator. Yeah, it's a pure mechanical thing that looks nice. Maybe I should put it on my desk. And that's the back side where all the hoses came from that went to this indicator unit. There's some sort of spray bottle, maybe a reservoir for oxygen, or I don't know what. I like this quick release connections here. If you have the right tool, they are even better. This is not the right tool, but it works. You have to push the ring in, and then you can simply plug that hose out. And if you want to plug it in, you just make like this. And the more you pull, the more it gets fixed until you push that ring back. And then it comes out. Very easy, very nice, and very reusable. Okay, what's the gray cables? Oh, some optical sensors. Let me show you that. We have here 2 optical sensors with 3, I don't know, a light source and 3 sensors, I don't know, and something that plugs on here. And I think these sensors are made to monitor some gas ratios with a certain absorbing spectrum analyzing thing. That's one sensor here and the other one there. Maybe we should have a look, a closer one on these things. Could be interesting if I can get them out. I really like these small hose connectors. They are so clever and they are easy like Lego. You can turn them in either direction. This is a rotary seal here. Even under pressure you can move them around if you want. And you just have to unscrew this, and because it's a moving part here, you can also screw it in. Oops, I'm off the camera. You can screw that part. Focus, you fuck. Oh, it helps. My camera has that feature too. Okay, so you can turn that. You just screw it in and then you set it into the direction you want. And you plug in the hose and everything is fine. And for the straight ones, it's about the same. Just take a number 8 millimeter key wrench and you're in like Flynn or whoever that Flynn guy is. Okay, come on. And the best part of all are the little adapter thingies here, like this one, which is a little bit difficult to reach if you don't have the right tool. Okay, like this. Ooh, it's getting black there. For example, a two in one piece, which fits perfectly into the next piece, like this. Then you have a connection for two hoses. For example, like this and like that. You screw it on. Just what I said, it's like Lego, and you take it apart and it's easy to play with, and it's good for, I don't know, 10 bars or 15. Just press down the ring, and you even have it color coded. You have the blue ring for the blue line, a white ring for the white hose line. White is oxygen, blue is nitrous oxide, black is air, white again oxygen, okay, from another source. It's like playing Lego and everything is for free. Yippee! I will put them in my big collection of pneumatic parts. And maybe the next device I will build is something with pistons and pneumatics, which is quite nice. So the last one comes out easily. Then we have more hoses to use, black and white, which is oxygen and air mixed, perhaps. I don't know what it means. Okay. And of course you can have these hose connectors with different size of threads, like this one, which is a bigger one. Oops, off camera. Like that one. So to compare it, that's the smaller one. Okay. That's a nice part. This is pressurized oxygen. Yes, white line oxygen. It has here a needle, a jet, some sort, and a big hole on each side. This is acts like a venturi valve. It injects here pressurized oxygen, and then air goes in here and mixes together and goes through that hose here. So this is a venturi injector valve thing. Very nice made. Could be used for something. You can use this to make a vacuum here, for example. Maybe this is not designed to make a vacuum, but it would certainly work. Or you could attach some kind of container with, for example, paint, and then you have a paint, spray paint gun. Of course, you have to block the second hole here. Or, well, you can use it as a mixing device for different gases or gas with air. For example, if you put in propane, you have a flamethrower. Nice part. Okay, that's the secret of this unit here. There are pressure regulators for oxygen, nitrous oxide and air that comes in from bottles or from the hospital supply lines, which go to all the surgery rooms, operation rooms. Ooh, strange brand, never heard of that. Dudenus. Is it French? I don't know. Noise. Dudine's noise. No, it's not German. Okay, whatever. The pressure regulator come from USA, Cincinnati, made in the USA. Okay. Also a very nice looking part, very expensive looking part. Here the different outlets or maybe inlets, I don't know. And other stuff. I think that's the lines that go to the indicators. Okay. A small detail on this CO2 carbon dioxide filter. It unscrews like this, and then it has a long chain for not to lose that cover. You can also remove that one, which is all stainless, of course, and it's not even, certainly not the cheap stainless stuff. It's the good one that is immune against all the chemical compounds, moisture, everything. We have some gaskets. They are quite well. Don't know what kind of rubber this is. Some silicon kind stuff. Okay, but I got myself 1 meter of nice ball chain. Another interesting detail is on the upper side of this filter unit here. This is the inlet and the outlet that go to the, I don't know, to the patient or wherever. If you unscrew this, you see this very thin ceramic disc here, which is a valve that closes when air or whatever gas we have wants to go that way, and it opens up when the air comes up through that hole. It is about, I don't know, a couple of tenths of millimeters. It's extremely light. It's ceramic, and it's certainly, oh, it's incredibly strong. Yeah, it breaks. So it's clearly a ceramic material, very light, has to move in the airflow. There is a second valve. It just has a cover here, some restrictors. It's another disc. It's the same as the one before. It's the same kind of valve. Can we move that? No. We also have a blue gasket here. Gasketeer. It's not a musketeer. Then quick release hose connections. Very nice. Very good for example, for an airbrush gun. I think I will keep that too. Okay, last part salvaged. A pneumatic button. Input, output, or other way around. You push it, it comes out what you put in. Okay. I don't know where I can use a pneumatic button, but that's one. Okay, thanks for watching.